Hello. This will be a demonstration of Proposition 28 from Book 9 of Euclid's Elements, which says that the product of any number and an even number is an even number as well. And we'll note from the outset, this enunciation I've written slightly differently from Euclid's. Euclid's enunciation restricts it to just the product of an odd number and an even number, but he also lacks a proof that an even number multiplied by an even number makes another even number, but the proof of that would just be the exact same as this one. It actually doesn't matter that one of our numbers here is odd, so I've just lumped these two together to say that the product of any number and an even number is an even number. With that said, we're given two numbers, a, which is either odd or even, it doesn't matter, and we're given the number b, and b is specifically an even number. We're also given their product. We're going to call that the number c. What we want to prove with this proposition is that their product, the number c, is an even number. Now, because the number a multiplied by the number b makes the number c, that's how we define the number c in our given, we know that there are as many b's in c as there are units in a. That follows simply from the definition of multiplication, which is definition 715. There are as many units in A as there are B's in C, which then means that the number C is a sum of B's. But we know the number B is an even number. We were given that. And we know from Proposition 9.21 that the sum of any number of even numbers is even as well. So that because the number b is even and the number c is a sum of even numbers, the number c is itself an even number, which is what we set out to prove, which means we're done with the proposition, therefore, etc., QED. We can see this proposition work both ways. If we preserve an even number in our product, it doesn't matter if we multiply it by an odd number or an even number, the product we get will still be an even number. So here I've done two examples. 4, which is an even number, multiplied by the odd number 5 makes the product 20. And the even number 4 multiplied by the even number 6 makes the other even number 24. What this proposition is going to tell us is that these products right here, 20 and 24, they are both even numbers. And this simply follows from the definition of multiplication, because 20 is 5 fours. And 24 is 6 fours. And we know from Proposition 9.21 that the sum of any number of even numbers is also an even number itself, so that because 20 is 5 fours, 20 is even, and because 24 is 6 fours, 24 is even. That's all I've got to say about this proposition, so I'll end the video here and move on to Proposition 9.29.